Hello everyone. Today we are discuss about fault tolerance techniques. Fault tolerance is defined informally as the ability of a system to deliver the expected service even in the presence of fault. A common misconception about real-time computing is that fault tolerance is orthogonal to real-time requirements. It is often assumed that the availability and reliability requirements of a system can be addressed independent of its timing constraints. A real-time system may fail to function correctly either because of errors in its hardware and or software or because of not responding in time to meet the timing requirements that are usually imposed by its environment. Hardware fault is some physical defects that can cause a component to malfunction. Software fault is a bug that can cause a program to fail for a given set of inputs. An error is a manifestation of a fault. The fault latency is the duration between the onset of a fault and its manifestation as an error. An error latency is a duration between when an error is produced and when it is either recognized as an error or cases the failure of the system. Error recovery is the process by which the system attempts to recover from the effects of an error. Recovery from an error is fundamental to fault tolerance. Two main forms of recovery: forward error recovery, backward error recovery. Forward error recovery attempt to bring system to a new stable state from which it is possible to proceed, applied in situation where the nature if error are known and a reset can be applied. Forward error recovery continues from an erroneous state by making selective corrections to the system state. This includes making safe the controlled environment which may be hazardous or damaged because of the failure. It is system specified and depends on accurate predictions of the location and case of error. Therefore, damage assessment. Examples: redundant pointers in data structure and the use of self-correcting codes such as scamming codes. Advantage: forward error recovery, less overhead. Disadvantages: in order to work, all potential errors need to be accounted for up front. Limited use, therefore, that is only when impact of faults understood, cannot be used as general mechanism for error recovery designed specifically for a particular system. Backward recovery, most extensively used in distributed systems and generally safest. It can be incorporated into middleware layer. Backward recovery is complicated in the case of process, machine or network failure, but no guarantee that same fault may occur again. It cannot be applied to irreversible non-idempotent operation, for example ATM withdrawal. Advantage for backward error recovery: simple to implement, can be used as general recovery mechanism, capable of providing recovery from arbitrary damage. Disadvantages of backward recovery: checkpointing can be very expensive, especially when errors are very rare. Performance penalty, no guarantee that fault does not occur again. Some components cannot be recovered. Cases of failure: there are three cases of failure: errors in the specification or design, defects in the components, third one, environmental effects. Mistake in the specification and design are very difficult to guard against. Many hardware failures and all software failures occurs such mistake. If the specification is wrong, everything that process proceeds through it. Design and implementation likely to be unsatisfactory. Fault types. Fault are classified as temporal, behavioral and output behavior. Temporal behavior classification. Fault are three types: permanent, intermittent and transient. Transient fault. These occur once and then disappear. For example, a network message transmission times out but work fine when attempted a second time. Intermittent fault. These are the most annoying of component fault. This fault is characterized by a fault occurring, then vanishing again, then occurring. An example of this kind of fault is a loose connection. Permanent fault. This fault is persistent. It continues to exist until the faulty component is repaired or replaced. Example of this fault are disk head crashes, software bugs, and burnout hardware. Output behavior classification. Malicious fault, inconsistent output. Non-malicious fault, consistent output, error. A fail stop. A response to up to a certain maximum number of failure by simply stopping rather than putting out incorrect outputs. The component simply stops working. For instance, a hard disk which refuses to read or write. Fail safe. Its failure mode is based so that the application process does not suffer catastrophe upon failures. A component under too much load is likely to fail. A fail-safe system, on detecting a large amount of load, process each request slower to avoid failure. Independent and correlation. Component failures too may be independent and correlated. Independent. A failure is said to be independent. It does not directly or indirectly cause another failure. Correlated. If the failure is said to be correlated if they are related in some way. Thank you.